This is a video on how to calculate percent error. Here's our formula. Percent error is equal to value observed minus value expected divided by the value expected multiplied all of that by 100%. So let's look at a problem to start with. You measure the mass of a chemical reaction to be 4.53 grams. According to your theoretical calculations, you should have obtained 4.51 grams. What is the percentage error of your work? Well, we're first going to start with our formula, which is the value observed minus the value expected divided by value expected multiplied by 100%. So let's find those in our problem. Well, first look for the value observed. And the value observed, well, it says you measure the mass of a chemical reaction to be 4.53. So here's our observed. Then let's look for our expected, which is over here. Expected. So let's plug these into our formula, or as I like to call it, plug and chug. So the value observed, which was 4.53 grams, minus our observed 4.51 grams over our expected, which is 4.51 grams. And then we are going to multiply that by 100%. I could just put this all in the calculator, but I am going to break it down whereas to more easily understand this. So we'll subtract first our 4.53 minus our 4.51, which will get us 0.02 grams over 4.51 grams. I'm just bringing this down. Okay. Now we're going to do the fraction or the division. That divided by 4.51 grams, which will be 0.00443 da 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 da. I have it in the calculator. You multiply that times 100%, and our answer is going to be 0.44%. So our percentage of error is 0.44% above the expected number. Let's try another problem. All right. The density of gold is 19.3 grams per centimeters cubed. Calculate the percentage error of an experimental determined density of 22.5 grams per centimeters cubed. So we're starting with our formula again. We're going to look back at this. We're going to have our value observed minus our value expected divided by our value expected times all of that times 100. So let's look for our value observed, which is in red. It tells us that experimentally determined density of 22.5 grams per centimeters cubed. That is our observed. And our expected, what we should have expected, is our 19.3 grams per centimeters cubed. So let's put that into our formula. We have our observed first, which is 22.5 grams per centimeters cubed, minus 19.3 grams per centimeters cubed. All of that under fraction over 19.3 grams per centimeters cubed. And all of that is multiplied by 100%. So let's work out the math. 22.5 minus 19.3 is equal to 3.2 grams per centimeters cubed over 19.3 grams per centimeters cubed. Then you multiply all that by 100, but we haven't gotten there yet. Next, we're going to divide, because it's in the parentheses, order of operations, 3.2 divided by 19.3, which is equal to 0.1658 dot dot dot, etc. times 100. This will be equal to 16.58%. And this is, again, because it's positive, above the expected number. Let's look at another problem. The density of aluminum is 2.7 grams per centimeters cubed. Calculate the percentage error of an experimentally determined density of 3.5 grams per centimeters cubed. Let's look at our formula real quick. We're going to go over the value observed minus the value expected. All of that divided by the value expected. And all of that multiplied by 100%. So let's find our stuff. Our observed is right here because it says experimentally determined 3.5 grams per centimeters cubed. And our expected is 2.7 grams per centimeters cubed. Let's plug it into our formula. We have the value observed, which is 3.5 grams per centimeters cubed, minus our expected, which is 2.7 grams per centimeters cubed. All of that divided by 2.7 grams per centimeters cubed, and then all of that multiplied by 100%. Could do it all in one go on the calculator, but we're going to split it up. So 3.5 minus 2.7 is 0.8 over 2.7 grams per centimeters cubed. And then those two multiplied by 100%. Those divided, 0.8 divided by 2.7 is going to give us 0.296296, etc. We're going to multiply that by 100%, and we get 29.629. I'm going to round to the nearest hundredths place. This 2, we're going to look back at this 9. This 9 is bigger than a 5, so this 2 becomes a 3. So it's 29.63%. Our margin of error is above what we were looking for. Let's do one more. All right. You measure the mass of a product of a chemical reaction to be 12.7 grams. According to your theoretical calculations, you should have obtained 15.4 grams. What is the percentage error of your work? Well, I'm going to tell you again. First thing we do is we're going to look at our formula. We're going to look for our value observed minus our value expected. Those divided by the value expected. And all of this multiplied by 100%. All right, so let's find what we're looking for. First is our value observed. So it says here that according to your theoretical calculations, you should have obtained 15.4. That is our expected. And so the first part, you measure the mass. This is our observed. 12.7 is our observed. 15.4 is our expected. So let's plug it into our formula. We first go with our observed, which is 12.7 grams minus our expected 15.4 grams over our expected 15.4 grams. Multiply all of that by 100%, and let's work this out. So 12.7 minus 15.4 is going to give us negative 2.7 grams over 15.4 grams. Then you're going to multiply all that by 100%. After we do that, we're going to divide 15.4, which will give us negative 0.1753, yada, yada, yada. I have it in my calculator. Multiplied by 100%. And that will give us negative 17.5324, da 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 da. I'm going to round to the nearest hundredth. I'm going to look at this 3. This 2 is lower than a 5, so this 3 is going to stay the same. So our answer, negative 17.53%. All this negative means is it is below the calculations we're trying to find. It's below what we're expecting. And so the answer could be 17.53% below. That's all that negative means.